Hi, I'm Dave Hefner, and I wanted to step through some tips and tricks. This is kind of a smattering, best of from my tip newsletter. Every week for the last year, I've been writing and publishing a Selenium tip, and they're all available for free on my website. And I recently went through them and kind of started pulling out kind of a best of anthology. And most of them are written in Ruby, but I'm slowly working on porting them over to other languages. And so the examples I'm going to show you are Ruby, but I'm confident with a little bit of work, they're applicable ideas for any language. So hopefully this is useful. And I'll step through each of the examples. I like to think that for those of you that aren't experienced with Ruby, it reads a lot like English. It's very idiomatic, so it's sometimes it does things that look like magic compared to just something like Java, but ultimately the concepts are pretty simple. So, and typically what I do is I write my examples against an open source web app that I have called the Internet. And right now it's up to about, I think, like 35 different examples of things that are common that you find on the web. Things like login, forgot password, that kind of stuff, tables, et cetera, et cetera. Anything you can kind of think of. And then if there's something that's missing, I always encourage pull requests. Or if someone requests a feature and I have the bandwidth, I can oftentimes add it as well. But this has been helpful for me, at least, to demo use cases for automated testing. And there are people who are using it for kind of calibrating their own automated tests as well. So there's no particular order to these tips. They're kind of chunked together. But let's just dig in and see where we end up. And also feel free to ask questions during if you feel inclined. So the first one is, I want to talk a little bit about headless testing. Seems like either people know what it is or they don't. And if they don't know what headless testing is, then they don't realize that there are several ways to do it. So how many people are familiar with headless testing? Okay. So the concept of headless testing is, instead of you loading a full browser, in a visible terminal window, you could potentially have it load somewhere else or use something that doesn't launch a full browser. It potentially just runs the underpinnings, like the JavaScript rendering library or something like that. So the first headless option is something like XVFB, which is it's a virtual frame buffer. This is the Wikipedia snippet on like what it is, but it's a virtual frame buffer, so it's an in-memory display. And it's ideal for Unix-like operating systems, typically Linux, most likely your continuous integration server. And it enables you to run graphical applications like a full browser, not in an actual term, it's just in this in-memory display, while enabling you to also take screenshots. So on a CI server, it's typically not going to have a monitor attached to it. It might just be a virtual machine. And this is one way to take the exact same tests that run on your computer, put them on a Linux machine, and still have them work and get screenshots and that kind of stuff. So this is a pretty good option, especially since most Linux servers, with the exception of people that use a lot of Microsoft, have access to this. And it's free. So a couple options. You have to install it. So if you're using Linux, then there's usually a package manager of some kind. So apt-get install XVFB, pretty straightforward. But then once you have it, you have to set a display variable, an environment variable. And then once you have that set for that bash prompt, you can actually launch your whatever it is. In this case, it's a Ruby script. But then say this Ruby script opens an instance of Selenium, which opens Firefox. Firefox would open in this virtual display port, this display 99. Option 2, when you install XVFB, is there's actually a binary that you can use to run a command. So as the previous one, you have to be in control of starting and stopping this virtual application, this will actually take care of setting the display value for you, run the app, and then close it down afterwards. And then if you're using Ruby, there's always a gem. Gems are the third-party libraries in Ruby. And there's one called Headless that just makes it so it's a very simple bit of script to make your test set up and tear down this virtual frame buffer. So this is a simple Ruby script, a very rudiment. It's not even using really a test framework. It's just a simple script that happens to have some assertions. Most of my tips are written that way because I don't want to weigh them down with teaching someone a framework and then teaching them a Selenium concept. So all that this tip has is it pulls in the libraries, Selenium WebDriver to drive the browser. RSpec expectations is how I do assertions. Gives you very readable assertions, read a lot like English. And then you require this headless gem. And then in the setup, you create an instance of the headless library. You start the headless instance, and then you start Firefox. And then once you're tearing down, after you close the browser session, you can destroy the headless instance. And then the magic that's happening is this, you'll see throughout all of my examples, is this yield and this run block. So all I'm doing is basically injecting this code, sandwiching it between the setup and teardown, so that whenever I create a run block, it's effectively just a test method. So, but all this is doing is, this is a very simple test. It's just loading the home page and checking the title. And when you run it with XVFB, it should just work. But the limitation for XVFB is that it's pretty much only Linux. So there are better ways, something like Ghost Driver. How many people are familiar with Phantom.js? A decent number. So so Ghost Driver is the WebDriver implementation for Phantom.js. And Phantom.js is a headless browser that uses WebKit under the hood to render your pages. It is entirely headless, it's pretty fast, and still enables you to get screenshots of the page. So step one, you have to download the binary. Ghost Driver is fortunately built into Phantom.js. So if you download Phantom.js, you actually get Ghost Driver. And then you have to start Phantom.js using a -- WebDriver flag, which looks like this, and you can specify the port. So you can actually have numerous Phantom.js instances running, and the fun bit about this is you can also add Phantom.js nodes to a Selenium grid if you wanted to. And then you just have to connect your test using Selenium Remote to this headless browser. So what this looks like in taking the similar example from last time, instead of doing headless with the headless gem, we're going to use the remote agent and connect to the URL on the port that we just started in the terminal session. And then the test will run the same, but it will run without launching Firefox. It'll just launch in Phantom.js. So that's really kind of the real crash course on headless testing options. So hopefully that's helpful for like kind of setting up on CI. So kind of changing gears, one of the most common issues or questions that are brought up is how do you test status codes, especially if you're using something like Selenium, because you used to be able to ask Selenium for the status code of something, and then the committers removed that feature because it didn't necessarily mimic human action. And there's this one specific open issue that pains a lot of the core committers because people still bring it up, like, why did you take this out? And just constantly comments, people coming in and adding to this closed issue that's like, this is no longer a feature. So I did an example right up on how to do status codes. And honestly, there's some interesting edge cases when it comes to checking status codes that people aren't necessarily aware of. But, and I think that Selenium is probably not the right tool for the job. But here's how you do it anyway. So So these next few tips will cover how to use a proxy server. Have any of you used a proxy server or know what that is? It might be a different name for most of you. I don't know. But the quick gist of how this all kind of cobbles together, you have Selenium, which connects to a browser. You configure your browser so that it connects through a proxy server, and that acts as a kind of a barrier between the browser and the application. And with the proxy server, you can monitor traffic and manipulate it so that you can do all kinds of fun stuff. And one of those things is grabbing status codes out of things that load, out of pages, out of resources, that kind of thing. And in Ruby and in a lot of languages, I guess, a popular proxy server is browser mob proxy. Patrick Lightbody, who used to be a pretty active member in the Selenium community, I think he's still on the committee. He has this open source project, and it works really well. It has a REST API that you can interact with to control the proxy, and then there's some people built some language bindings to make it easier to use. So in Ruby, there's actually a third-party gem to do that. And so that's the link, bmp.lightbody.net. So in Ruby, with this browser mob proxy library, this configure proxy method is where the meat of it's happening. It's first creating a browser mob proxy server object, and then you actually have to download the binary and then tell this library where it is. So once you do that, you can then create the proxy. You can start it. And then you have to configure your browser profile to consume it, to actually point at the proxy. And then once you've done that, you tell Selenium, here is the profile configuration. So when you're doing a local instance, you just have a profile flag. But if you're doing Selenium remote, it would be desired capabilities. And so then once you have that, and then you have our general setup and teardown and our run, the actual test method is here. And before that, we actually have, we're wrapping an action where we're actually creating and getting HTTP archive, which the command newhar does. And once the command executes, it grabs the response status out of it. So when that's applied in this test here, it's actually loading this page, and this example page on the internet, this status codes page, whatever number you throw at it, it will return that status code. So if you go to a 404, like we're doing here, it gives a 404 status code. So when we do that, retrieve status code, it's going to pluck out the status code from the HTTP archive from the proxy server, and then we're going to assert that it actually was a 404. So a little bit extra work, but now we can check status codes off of URLs using Selenium. So that's one thing. A better use of a proxy server is something like blacklisting, which how many people are familiar with the term blacklisting? The ability to it's basically the ability to block third-party resources that you don't want mucking up or slowing down your tests. So what you can do is actually match for certain resources using like a regular expression, and whenever that tries to load, instead of it loading, you can replace it with a different status code. So if you have a slow loading set of assets, you can swap them out for 404s. And then they just won't load. They'll just be set aside. So kind of taking a similar approach from the last example, after you create the proxy, you can use the blacklist command. And in this example, this is a slow external example. There's a resource on the page that takes like 30 or 90 seconds to load. And so what I do is just you grab it with a regular expression and you say, all right, make that return a 404 instead. And so in the actual test, similar to last time, doing a new har, but we're not doing any fancy wrapping for it. We get the page, and then we grab all of the entries, and then we find the one that has slow external in the URL, and then we expect the return not to be nil, and we also expect the status code to be 404. So we expect the resource to have loaded as a 404, basically. So now when the test runs, like before, if I wasn't doing this, it would take the full 90 seconds before the page would finish loading and potentially slow down my test. Now it just doesn't, it's just an instant. It just sees it, shuts it down, gives a 404. So pretty useful if you want to block images and sprites and other kinds of things that could just be really annoying for your tests, especially if they're outside of your control. So that brings me to one of the more interesting use cases I found for using a proxy server, load testing. How many people here do load testing? A fair number. Cool, cool. So using a proxy server, I found that you can actually capture the HTTP archive and convert it to a JMeter JMX file, which this might be child's play for you guys. So, so after you configure your proxy server and capture the traffic, and I have this converter that runs. So you grab the har file and you pass it on into this har to JMX converter, and don't worry about exactly what's happening here. I borrowed this from a working example from the Ruby JMeter library, which this is from one of the JMeter cloud providers. They're the ones that maintain the Ruby JMeter library. And so this just takes the har file, converts it to JMeter JMX. And so what you end up with is a har file and a JMeter JMX file. So if you open up and you could view the har file for the page that was in this example, it looks like this. And then, which has all the different load times and assets. And then if you open up the JMeter JMX file, it has the same asset calls. So it's kind of like matching for parity. But it's like, hey, now we have the beginnings of a load testing script, which we can use and run from anywhere. So I thought that was kind of useful. So kind of starting to close out the whole proxy server angle, broken image checking. So with broken images on a page, I found 3 ways to verify if they exist. There's actually 4, but I won't talk about the 4th. So there's using a proxy server, there's using an HTTP library, and then there is JavaScript. So the last proxy example, after you have set everything up, and then say if you go to a page that has broken images, you get all the images, and then if you iterate through each one, match the source and check the har, the HTTP archive, for bad response codes, and then every bad response code you get, you can store in a collection, and then assert that the collection is empty when you're done. And if it's empty, congratulations, you have no broken images on the page. And if it's not, then you do, and you can find out what they are and where they are. So the better approach, which is probably a good deal faster, is to use an HTTP library. There's numerous HTTP libraries in Ruby, and I'm assuming there's numerous in whatever language you're more proficient in. But something simple like REST client. And it looks kind of like this when you run your test. Same as before, but we're also requiring the REST client library and grabbing all the images. But this time, we're actually using REST client to make a request to each of the resources, and then we're expecting that the status code for each of them will be 200. And this will be like an order of magnitude faster than the previous example, at least. So the third option, to kind of keep everything within Selenium, is to use JavaScript. So once you have your simple test set up and teardown, if you load the page, and what you can do is actually execute JavaScript that will look for undefined and onerous width of an element that are images. So you can kind of sift through all the images and see are they listed as undefined, and are they of a size greater than 0, and collect and assert like before. And that way, I mean, it's not as fast as the last example, but it keeps you within Selenium and just executing JavaScript. So it's like whichever way works best for you, which one you're more comfortable with, but there are options. So you can check broken images. And if you really wanted to get fancy, you could just do visual testing. I don't know if any of you saw Moshe Millman's visual testing talk, like something like WebDriver CSS or Applitools, fantastic tooling. I've actually done several write-ups on visual testing, but I omitted them from these tips because I could give a very lengthy talk on just visual testing. So, but worth a look if you've got a chance to look at visual testing. So, another one that's interesting to me is forgot password, because the very notion that you go to a page, you trigger an action, and then it takes you out of band from that workflow. It sends an email. And so what do you do? And so I'm a big fan of trying to keep everything in as simple as possible. I'd like to consider myself a very lazy person. And so forgot password always gave me some heartburn, but I found what I think is a reasonable solution. There's much more clever ones and probably more robust, but something as simple as if you send a forgot password email to a Gmail account, instead of actually using the browser to go and get it, there's third-party libraries that go through the REST endpoint of Gmail, and then you can just grab the link out of the email and then load that in the existing session, your Selenium session, the one that triggered the forgot password email. And so what that looks like, simple setup and teardown as before, but there is this retry loop that I've created because the emails don't always immediately show up for forgot password. So you want it to try as many times as you specify, because something like an explicit wait only works for Selenium, so you have to write your own if you're using some third-party library. So and then when you actually wire this up to a test and you use this Gmail library, so this is what it looks like on the forgot password page. There's an input field. Just you plug in your email, and then submit it, and then you just leave the session active, the Selenium browser session, and then you launch an instance of this Gmail library, and then try numerous times and look for new mail from this address, which is coming from the internet, this no reply email, and then once you have it, grab the message body. And then parse the message body for a link. And then once you have it, make sure you can strip out what you need, and then basically take the existing Selenium session, visit that URL, plug in the username and password, and then submit, and then make sure that you actually ended up on a secure page. And by doing this makes this approach was a lot more stable than trying to go through someone else's front end where locators are constantly changing, that could be prone to issues that I don't know what, but instead going through the API solve that. I'm still uncomfortable about going through someone's production endpoint to pull information out to test something that's like a staging environment for me, but it's kind of when you don't have any other option, this is a pretty good option. So speaking of things that could potentially be outside of your control, something like split testing. How many people are familiar with A/B testing or split testing? I apologize, but here's a lot of text. I'll read it really quick. Split testing is a simple way to experiment with an application's features to see which changes lead to higher user engagement. So a simple example would be testing variations of an email landing page to see if more people sign up. In this kind of a split test, there would be what's called a control, how the application looks and behaves now, and then variants of the control, like 2 or 3 of them that you'd want to test, and that would include like changing things on the page like text or the way the elements are positioned or the color of the submit button, those kinds of things. And then once the variants are configured, they're put into rotation, into view of public use. And the experiment starts. And during this experiment, each user is going to see a different version when they load the page of this feature. And then everything that they do on that page will be tracked. And then split tests will live on, these experiments will live for a length that you predefine, or until a winner is found. So 2 weeks or until you have enough data that's statistically relevant to show that one feature is better than another. You track things like conversions, like did someone sign up or did someone buy something? And if no winner is found, you keep the control, try out some new variants, and run another experiment. So there's plenty of services that handle this. Something like Optimizely is a pretty common one that I found. And so I put together an example on the internet that uses Optimizely, and there's 3 different states. There is the control, one variant, and nothing, like if you're outside of the experiment. And so each split testing provider is different, and some people have their own homegrown solutions. I think there's ways to get really creative in terms of figuring out what experiments are running, and then adding your test into that experiment group so that you can verify that it's doing what you expect. But odds are, a lot of times, the experiments are changing a lot, and so it's hard to keep up with them. So your test could be prone to break without you realizing who changed something. So rather than try to jump through and be clever, I think it's easier just to opt out of A/B tests altogether. Make sure you're just not in a test group, and that or force yourself into the control. So with Optimizely, they have a couple of different ways you can opt out of the split tests. So after you have your setup and teardown, there's a few different options. So the example on the internet is just /AB test. And in this first example, I grabbed the thing that changes on the page is the header text. So grab the heading text, and then I expect it to be potentially it's either going to be in the A/B variation or the control. So it's either in the experiment or the control. And then with Optimizely, you can add a cookie that says opt out. And then when you refresh the page, we find the text again from the header, and then it should just say no A/B test. That's when you're outside of the experiment. And so alternatively, you could just go to the home page, load the cookie, and then go to the experiment page. And you could also just toggle based on a URL. But when that happens, it triggers a JavaScript alert that you can then just dismiss. But ultimately, it should take you out. So knowing what the out of experiment condition looks like is helpful to make sure that you actually end up there. And that might not be the case in your environment, but I think opting out of A/B tests will help reduce the amount of fluctuation in your environment that's outside of your control. Okay. Next. Downloading a file. I've actually written about this 3 times because it's not straightforward. So a lot of times people think, I want to download a file. I want to test that it works. So let me just configure my browser to download this file, and then I'll inspect the file after, which you can do, but unfortunately it's inconsistent configurations across all browsers. So that's challenging. And also it's kind of heavy to test downloading a file when there's better ways to do it. So the first example is if you wanted to configure your browser, here's what it looks like. Here's Firefox in the top portion. You have to create a profile object, and then you have to tell it the download directory. You have to tell it what behavior for the download directory. Do I use the last folder I specified or something else? And there's that, and it just takes numbers that are obscure and may or may not be well documented. Documentation's pretty old for it. And then you tell it which types of MIME types you want to save to disk. And then you have to make sure you disable the PDF viewer just in case it happens to be a PDF, or else it'll view it in the page and won't download it. And then you're good to go. But that's only Firefox. If you want Chrome, you have to do something different that involves kind of this hash map thing. And then Internet Explorer, pretty sure that's harder just by default. And then once you actually get it, you want to make sure the file you download is unique. So you want to handle some of that with maybe some sort of unique identifier. And then you want to clean it up after. And so that's all well and good. But that seems like a lot of work. Instead of doing all that, what we could do is actually use an HTTP library like REST client or something else. And this is it. This is the whole example. What you can do is you go to the page, you grab the link or links that you want to test downloading on, and instead of actually doing a full download, you can make a head request to the link, and it will give you a response with the headers that you can inspect. And you can just check that the content type is the MIME type you expect, and that the length isn't empty. Make sure it's greater than 0, and then you avoid getting a full download. Unless you actually have something that's rendered that you want to inspect after the fact, but that's a whole different use case. But for majority of the time, doing something like this is a lot better, probably a lot more applicable. And then if it's secure files, you'll want to pull out the session information from the page and then pass that into your HTTP library. And so for this example, there's a cookie that's rack session. This is a rack app for the internet. And this example is behind basic auth. And then, so all these, once you're behind basic auth, all these links will be HTTPS. So you still need to be authed for the HTTP library. But once you pass all that information in, it's just the same as before. The content type is what I expect, and the file size is not empty. And if you really wanted to get fancy, if you had more than one file and more than one MIME type, you'd probably want to create some sort of conditional check to say, if I'm looking for a file and the file type is .jpeg, here's the MIME type. If it's PDF, here's the MIME type. And if it's not those, raise an error. And then you can actually loop through them and then check for the content type. And the cool thing is you could just pass the URL and we can pull out the base name of the file. So it saves some heavy lifting. I'm assuming this is 10 times as long in Java to do, but sorry guys. And I want to kind of close out with these last couple where I think these are kind of fun. I think they're helpful too. So the concept of having sort of visual indicators of what your tests are doing, I think is interesting from a debugging perspective. So this one, these both leverage the same kind of mechanics under the hood of Selenium, but they both are different tactics. So highlighting elements, the concept that when you actually find an element, you can make it illuminate on the page. You can actually change the styling of it to see it. So what that looks like when you actually have a test wired up is you could just execute some JavaScript on an element and pass in whatever kind of styling. So in this case, I'm making a dashed red border around it. And that's pretty much it. And then once you actually just run your test and you just say highlight this element, and on a page that has a very tricky nested DOM, it's nice to know, what did I find? What is my test doing? Is it what I think it's doing? And granted, you could go the other way, and before you even find your locators, you could try to verify them with something like Firefinder. But this way, you can actually just take a look and see what your tests are actually doing now. And then to kind of piggyback on that, doing something like growl notifications. Are you guys familiar with growl notifications? It's like the when an event happens, like a notification pops up. It's very similar to on an iPhone when you get a text message, it pops up. They have it for Mac where it pops up in the top right if you get you need an update or you got an email. So there's a jQuery library called jQuery growl that you can add to a web page to send out those kind of growl notifications inside the DOM to the user. And so with Selenium, what you can do is you can actually use an event listener. And with an event listener, there is actually the ability to hook into the before and after actions of find element and those kinds of things. And with that, what we can do is actually have this wrapper that becomes our abstract listener. And what we can do is actually inject this the styling and the JavaScript library for jQuery growl into the page that we're viewing, and then display information. So when we navigate to a URL, we can say what in a growl notification, you just navigated to this URL. And you can say, oh, I found this element. Here is the locator you used. And then before you click, be like, oh, you're clicking on this element. And just have all this kind of debug output on the page, kind of trickling down the right side. And then when you, and then we of course have to add the ugly JavaScript and use that to inject everything in the page. Like we have to check and see if jQuery is on the page. If it's not, we'll add it. And so there's definitely a little bit of lifting that's going on. It's probably not as fine-tuned performance-wise, but it's pretty fast. And then it has to add the styles and all that. But then once it's done, it looks a little something like this. So if you're doing like some sort of video recording, you know exactly what's happening right when it's happening. So you get these, this is the URL changed to, and it gives you the URL, and then the previous page it was telling you right before you click something or find an element, that sort of thing. And how many people here use Java? Yeah, that's what I thought. So I have one example in Java. So, okay. Yeah. Okay, so let's see. Ta-da. Okay, so is that good? Okay, so the most common example I've found, which is good for kind of stepping everybody through a concept, is login. Right? Go to a login form, you fill in a username and password and submit. So I put together this example using Sauce Labs and Applitools. So say you wanted to visually verify that the layout of your page renders okay in Internet Explorer 8, but you don't have a machine that runs Internet Explorer 8. So using something like Applitools, you get, of course, the nice all the nice visual testing cues that they give. And then with Sauce Labs, you can get the browser that you want. And so this is kind of an iterative approach. So the first example is really just showing how to wire up Applitools to make sure that works. And then I add in everything, and I kind of clean it up. So this first, just login 1, login 2, login 3, login 4. So Applitools has their own SDK, and it's basically consumes a Selenium WebDriver object and returns a modified one. And then I just use JUnit and Selenium WebDriver. And so in the setup, in this example, it's just a really simple rudimentary local Firefox instance. I create an Applitools instance. I generally store my credentials using environment variables and pull them in. And then when you create an instance of eyes, you can tell it the name of the application and the name of the test. And then you keep all the Selenium actions, the loading the page, the inputting text, submitting the form. But you can add this thing called check window. And what this does is this is telling Applitools when to take a picture, when to capture an image. And so I do it for each time right before the page changes. So right when I'm at the login form, I capture an image. And right after I've submitted the login form, I capture an image. So I have I'm at the login form, now I'm logged in. And then this is my assertion just to see if this flash success message appeared after logging in. But Applitools has this eyes.close, which actually closes the session, but it's also doing a check against the baseline image to see if there's any changes. So if some sort of visual anomaly happened on the page, this will raise an exception and give you the URL to the job in Applitools, so that you can go and view the workflow and what happened and what was different. And simple teardown. If for some reason the session for Applitools didn't close, it will close it for you, and then the browser session closes. So the second one is adding in Sauce Labs support. With Sauce Labs, it's just they have their own SDK, but I don't use it. You just need to use Selenium Remote, and then you can actually connect to Sauce Labs really easily. So you just have to swap out your local browser setup for desired capabilities. And there's a couple ways to do desired capabilities. You can do a desired capability for a specific browser, or just do what I did here, which is just specify a blanket desired capabilities and then specify the browser name. And I'll show you the other way in the last example. But you basically say browser name, the version of the browser, and then which operating system that you want. So in this example, we're saying I want IE8 on Windows XP. And then just like before with Applitools, we have to specify a name for the test. Now, granted, these are all hard-coded values, so I'm going to show how to clean that up in a little bit. But for the Sauce URL, it's just a basic auth to their Selenium grid, basically. And so I just pull in the username and password, or username and access key, and then you create a remote WebDriver instance pointing at the URL for Sauce, and then passing in all of these capabilities. And then other than that, the Applitools setup stays the same. And then everything else stays the same. And then make sure nothing changed. Oh, right. So to clean up the display name so it's not hard-coded, I use a test watcher, a test rule, just to grab the display name and then feed that into Sauce Labs and into Applitools. That way it dynamically updates, so you have a bunch of tests. And then in the last example, if there is a failure, Applitools will show it in the test output. It'll give you the URL, but Sauce Labs won't. So what you can do is actually grab the session ID. So you just create a field for session ID here. And then after you've created the browser object, you can grab the session ID out of Selenium, and then that's actually the unique identifier that Sauce Labs gives you for the job. And so what you can do then is concatenate your own URL, or it's just saucelabs.com/test/session ID. And then if there's a failure, that will output into the test output into your console. And also, the thing I wanted to demo real quick, if you didn't want to specify the browser name in a string, then you can just do it by saying desired capabilities dot browser name. The documentation for Sauce Labs will showcase this example, but the approach that I was using before, where you can specify by string, it's a lot easier to make it configurable, because then it's a runtime property. You can specify however you want. So to each their own. So that's my Java example. Are there any questions? Okay, you guys are probably like, oh, I already know how to do all that. So that's it. If there's any questions, I'd love to answer them. Otherwise, please feel free to email me or tweet at me. I'm here to help. I love to answer questions. I want to try to help people figure out how to find information and make sure people aren't stuck like I was when I started doing testing. Or if there's just something that's really like, I feel like I'm so close, I just need more help. Like I'm happy to help answer questions. So please feel free to get in touch. So thank you.